Welcome everybody to a Khan Academy tutorial by Mr. West. Let's go ahead and get right into it. Here we have slope from 2 points. Now, a lot of students kind of struggle with slope at first, and I think once you get it and understand it, it makes a lot more sense. So, well, obviously. Anyway, so here we have a coordinate plane. I'm gonna go ahead and label these points first. So we have, I'm a very visual person. I don't know about you guys. That's why I like geometry the most. But all these other things are good too. So we have negative 2, 6, and 2, 2. So my other point, let's make it a purple point. We have negative 2, and then it could somewhere down here. So let's call that negative 2, 6. Okay, so if we have a line through these 2 points, okay, whoops, not the straightest of lines, but you get the idea. So if we have a line through these 2 points, we need to be able to figure out the slope, how steep it is. That's what it's asking. How steep is this slope? Now, slope is defined as the rise over the run. And some of you might be thinking, oh, my teacher said that all the time, and I don't even know what that means. Okay, let's think about this. What's the difference between a flat plane and then a steep mountain? Okay, well, a flat plane has a big horizontal distance, okay? But it doesn't raise very much at all. In a long distance horizontally, it barely goes up, okay? Now, let's think about a mountain. What makes a mountain so steep? Well, it's because it has a huge vertical distance and a short amount of time for the horizontal distance, okay? Comparatively speaking, slope is simply the ratio for how much something goes up and down versus how much it goes side to side. It's the vertical change over the horizontal change. And that ratio will tell you how steep something is. And we quantify that. Now, how do we measure vertical change when we're given coordinates and a coordinate plane and numbers and blah, 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 blah? Well, it's not as bad as you think, okay? So if we're looking at this scenario here with these 2 points, I'm going to draw my vertical change between them real quick. Okay, so we have this vertical change. Now, how many units does it go? You know what, I just realized? Oh, that's negative 6. Sorry, I was like, something does not look right here. This is supposed to be negative 6. Maybe some of you were thinking, "Oh my gosh, you wrote it wrong." Well, thank you. I heard you through the screen. So the vertical change here, how many units does it go up from the purple to the green? Well, we could count. We could go 1, 2, 3, 4, 5, 6. 6 takes us here, and then we go 1, 2 more to give us a total of 8. That is one way to do it. We could just sit there and count the lines, okay, the individual spaces to get 8 between those 2 points. Or there's another way. Since we're trying to find the distance there, we're essentially trying to find the difference between the y values. Okay, what's the difference between 2 and negative 6? And that will tell us how far it went. Okay, well, the difference is the same thing as subtraction. So we could subtract those 2 y values, and it would tell us the answer. Now, in order to distinguish which y value is which, we need to label it. Okay, so since this is a y value and this is the y value, we should probably label which ones differentiate between the two so we don't get confused. So let's call the one on the left y1 and the one on the right y2. Okay, so a lot of the times, well, I mean, it doesn't really matter, but a lot of the times people like to subtract the second point, the first point from the second point. So a way to find out the rise, the actual distance that it goes up, is to subtract your y values. Do y2 minus y1. Okay, now what do we do for the horizontal value? The horizontal change. Well, we can do the same thing. We can either start at the green point or the blue point. I started at the green point last time. Let me start at the purple point this time. So to find our distance, we just count 1, 2. 1, 2 takes us to the line. Then we have 3, 4. So that was a change of 4. So we counted, and it was 4 units. Well, again, if we wanted to find the change, the distance, we can find the difference between our x values. That's an x value, and that's an x value. But now we should label it so we don't get confused. So we need to label this one x1 and this one x2. You can't switch it. If you label this y1, you can't call that x2. You have to keep it consistent with the 1s and the 2s. So x1, y1, x2, y2. Another common mistake is you label the points x1, x2. Don't do that. Okay, there's an x and y value for each coordinate. Make sure you adhere to those rules. So again, how do we find the difference? We subtract the x values. So let's recap here. Rise is the difference in y's, and run is the difference in x. Another way to remember it is you rise with the y's and you run from your x, okay? So that's a way to remember it, just in case. Now, let's put it into practice. I'm taking a little bit too long on this first problem here. You're probably like, oh my gosh, I already know this. Just show me how to do it, okay? Well, I'm going to go. Give me a chance, jeez. So we have y2 minus y1, negative 6. Make sure you include the negative with the parenthesis, divided by, then we have 2 minus a negative 2. Well, we have to change the negative to positive, so we have 2 plus 6 in the top, 2 plus 2 in the bottom. What do we get? We get 8 in the top, 4 in the bottom. That's exactly what we got here. Okay, that essentially found our distance between those points, but now we simplify with the ratio. We know it's vertical change divided by the horizontal change, and that is 2. So our slope here for this problem is 2. So we're going to select 2. Okay, again, first thing you always want to do, okay, we're going to go a little bit quicker now, so you guys don't get impatient and hit unsubscribe and all that stuff and cancel me and all this other bad things. So our slope, and, oh, by the way, m is usually the variable for slope. So we have y2 minus y1, x2. You've seen this, okay? I don't even know why I wrote it again. I'm an idiot. So we have negative 9 minus 6, that's my y1, over negative 6 minus a negative 9, okay? Be careful with the negatives. The negatives are probably the thing that trip people up the most. We have negative 15 in the top, and we have positive 3 in the bottom. That's going to be equal to a negative 5. So that's our slope is a negative 5. Again, if you need a pause to write down and copy along with me, that's absolutely okay. Make sure you pause with a cause. x1, y1, x2, y2. We're going to do, our slope is going to be equal to, that's ugly 2. We have 3 minus a negative 2. And then we have 9 minus 2. So this is going to be equal to 5 over 7. And that's positive. So we have positive 5 over 7. 2 more to go. Almost there. All right. Last one. We'll go this orange. So we have x1, y1, x2, y2. Or is this red? Is this a red or an orange? I can't tell. Maybe leave a comment. Tell me what color this is. Negative 3 minus 2, then we have 3 minus a negative 4. Okay, we have negative 5 in the top, then we have positive 1 in the bottom. Wait, which one am I doing? Something's wrong. Negative 3 minus, oh, I got mixed up. Good thing it's multiple choice. It's a positive 3 minus a negative 4. That gives me a positive 7. So now I have a negative 5 over 7. Now, I always like to put it in the top, the negative sign. That way I always have a negative rise. I can talk about that in another video, but I always like putting the top, but here it doesn't really matter. We have negative 5 over 7 right here. Check it. All right, you're going to be hearing this sound of success. Thank you so much for watching, and I will see you next time on West Explains Best.